In today's world of barcode tracking and highly automated processes, it's becoming increasingly critical to add a barcode quality control step into the manufacturing system to help achieve the benefits of automatic data capture and ensure readability of barcodes throughout the supply chain. The correct ISO verification test is based on 10 scans taken over the full height of the barcode, but not including the top 10% and bottom 10% of the symbol. Take your 10 scans. On each scan, the verifier will draw itself a graph or profile of the reflected light from the barcode. This is the scan reflectance profile. The high points on the graph are the background spaces reflecting a lot of light. The low points on the graph are the bars reflecting less light. The verifier finds the brightest spots on the profile and the darkest spots. These are known as Rmax, the point of maximum reflectance, and Rmin, the point of minimum reflectance. It draws a line halfway between them. This line is the global threshold, and all of the linear measurements are taken along this line. The quiet zones are assessed for width. The contrast is measured at each bar edge and compared to the overall differences between Rmax and Rmin. The edge with the weakest contrast is identified. In this case, it's the fourth edge from the left. The verifier measures various attributes or parameters of the barcode by analysing the profile. Symbol contrast, a simple comparison between the brightest and darkest points. Minimum reflectance, Rmin, a check that the bars are dark enough relative to the spaces. Bars must be half the reflectance of the background or less. Minimum edge contrast, the contrast between each dark edge and the light edge touching it. If this is too low, then that edge may not be discernible to a scanner. Modulation, the contrast along each edge is expressed by a ratio of the symbol contrast, and the space that the verifier finds hardest to see is identified. Think of modulation in music, the rate at which tones rise and fall. If they do so too quickly, the music becomes discordant. In the same way, the variations in reflectance across the scan profile should occur smoothly, but a sudden space that is hard to see will interfere with the smooth rise and fall and will be a reflective bum note. Defects, dark spots on what should be light areas or vice versa. If they're too big, they'll create a spike or a dip in the profile that will cross the global threshold and appear to be a bar or a space that shouldn't be there. Decode, the verifier asks itself, am I sure that ordinary scanners in the world at large will be able to scan this? There is no grading for this. The answer is either yes, A, or no, F. Decode takes into account character encoding, check digits, and light margins. GS1 128 has two check digits, the one in the number that you can see and another the symbol check digit that is buried in the barcode and invisible to human observers. Decodability, an assessment of how easily decodable the barcode is based on a comparison between each individual character in the barcode and a perfect example of the same character in which all of the widths are exactly correct relative to each other. Here's an example of a defect caused by a thin white line down the centre of a printed bar. You can see that if it were high enough, it would touch the global threshold, shown at the blue line, and create the impression of a thin background space down the centre of the bar. On each scan, the verifier will report grades for each of the parameters and will report the poorest of all the grades it finds. The result is called the scan grade, the grade achieved in a single scan. The verifier averages the results of the 10 individual scans. This average result is called the symbol grade. Remember, this is very important. Each individual scan produces a scan grade. Passing or failing the test doesn't depend on these alone. Some individual scan grades may even be fails. Passing or failing depends on the ISO grade of the average of the scan grades, the symbol grade. So our barcode has achieved an ISO grade of 2.8. We know that it was an EAN 13, so we will have tested it with a 6mm scanner, or the verifier will have automatically selected 6mm if it was a type that chooses its own aperture. And the light source of most verifiers is 660 nanometers, so this will be stated in our result also. So our symbol grade is 2.806660. We know that 3 is B grade, and the B grade covers numbers 2.5 to 3.4. So our barcode achieved a grade of B. Because the grade is within the range 2.5 to 3.4, when we tested it with a 6mm scanner, on a verifier with a 660 nanometer light source. But what if it had failed? Now we must understand why.